The story starts basically with, ooh, we've got a mill. Now what? At my heart, I'm two things. I'm a reverse engineer, and I'm a toolmaker. Reverse engineering doesn't really get into this much, but I like making things that allow me to increase the things that I can make in the future. Even though this doesn't necessarily lead to ever making anything of actual, use. But there's a lot of tools having to do with metalworking that are mostly about being flat and square and smooth. Not so much smooth, to be honest. And things like that. The most basic tool is a pair of parallels, which are just two metal blocks of the same height. And normally also the same other dimensions, but the same height is the important one. That, you'd think, is trivial to make on a mill, and it mostly is. Except you want them to be absolutely positively flat, and you want the two sides to be absolutely parallel to each other. That's, in the name. It's a pair of parallels. The fact that it's a pair is really not in this discussion. The normal way you'd make something flat is with a machine called a surface grinder. You essentially have a grinding wheel, and the grinding wheel moves back and forth slowly across your workpiece, and forward and back as it does so, and grinds it flat. Which is a great way of doing it. It's the normal way of doing it. But it requires building a lapping machine, or building a surface grinder, rather, which is itself very flat and very rigid. And that's not really in, my capabilities. It's normally another machine on the same order of magnitude of price as the mill itself. It's huge, and yeah, just, it's not something space has. It's not something that space is probably going to get. So, the other way of doing it that's reasonably common is called lapping. In the classic lapping procedure, you've got 3 plates, and you rub the plates across each other with some abrasive in the middle, and that the idea being that every point on the surface of the one plate you're slotting about makes contact with every point on the surface of the other plate you're currently lapping together, which makes the two be flat relative to each other. If you only use 2 plates, one can be concave and the other can be convex, which is why you need 3, and you need to alternate between them. But that can actually get extremely flat results with no special equipment of any kind. But it's a slow process with lots of repetitive hand labor, and that would bore me to tears. I'm not great on the whole attention span thing. So then we get into machine lapping. The obvious way would be to just have 2 plates and have some sort of machine that slides them together. But doing that without introducing rocking soft motions and other irregularities I couldn't figure out how to make it work mechanically. So I started looking into how professionals do this. While lapping is not terribly common as an actual procedure, it's done for things you want extremely flat, even flatter than you get with a surface grinder. Normally after surface grinding, but we can just skip the surface grinding and go straight to lapping. A commercial lapping machine looks very little like 2 plates rubbing against each other. Instead, you have a large spinning disc on the bottom, and and those rings on the top, which spin about in opposite directions, and every point on each of the rings makes contact with every point on the plate, except the very center, because the geometry can't walk out. Yeah, there's just a hole there, you don't use the very center. Anyway, which gets you... well, it gets you closer to a two-plate lapping, with some of the third, because of the rotation of the rings, the conditioning rings, as they are technically called, because they're there in order to lap the lapping machine and keep it in good condition. Yes, we've got a video of this lapping machine in action.
I stole this off the internet because, you know.
So, are you guys still on, the same page as me?
Yep. What's it making flat? The circular bit underneath the rings?
So, yeah, what you're seeing there is just the machine itself with no actual, payload as well. It is, lapping itself flat, which is, the beauty of the whole lapping method. You don't need to start with something that's very flat, which is why I feel more comfortable making it than making a surface grinder. When you're actually using it for, some actual productive purpose, the thing you're trying to lap would be inside of one of those rings. In fact, commercially, it would be inside of, I believe, usually 2 of the 3, for some reason I haven't figured out, because you've got multiple parts you're trying to lap at once.
So on top of the plate and underneath the rings?
In the hollow center of the ring. Ideally, you've also got a way of keeping it steady relative to the ring, so that it doesn't smash against the sides.
Yeah.
But
no, so what you want to make flat has to fit in the middle of one of the rings?
Yes. Which is one of the reasons it has to be fairly big. The one I have made is kind of tiny. You can fit a large nut in it, but that's just the prototype. The one I'm making next is the size of a kitchen cabinet, mostly because it's a kitchen cabinet.
Useful enclosure.
Exactly. I could have made my own enclosure, but that's not what this project was about, so I just bought one. So, yeah, that's a good point to move on to the prototype, I think. Yeah. So, the very first prototype was almost completely 3D printed and a couple bearings, which obviously is not good for anything except getting a vague sense that this might be something that might work. So, we got the lovely Josh to make us the actual table, which, yeah, is just a... yeah, it's 10 centimeters diameter. It's, exactly the proportions you see on screen. The shaft is 8 millimeters diameter, which, if that helps you, get a sense of scale. So yeah, that is spun by a motor from an old hand drill. It still has the chuck on it, even, which is handy when you're trying to grip a cylindrical object. And the rest of it's 3D printed. Slide. You've got a, support structure, which is just there so it can sit flat on a table and be clamped to the table. It holds the motor. The motor spins the thing on a bearing. There's bits at the top to hold the rings and your workpiece, and the hose that delivers the oil with grit in it. And that's basically what there is to it.
Can I show something more?
Oh. So, one thing I haven't talked about yet is the actual abrasive that is removing the material until it becomes flat. The way it's done in industry seems to be with a mixture of oil and diamond or granite abrasive, which is kind of expensive. But I figured that instead of using various grades of diamond that are carefully created to have exactly one size of diamond in them, so that you can walk through grades of abrasive, I could just dump in sand if I can filter it to just include the sizes that I want. So a mixture of oil and sand goes in a hose at the top. It dribbles onto the plate. It, swooshes around for a while. It's eventually flung out the side, where that essentially drip tray catches it. And the bottom of the drip tray is slanted to that drain in the corner, where there's a hose attached to a perisystolic pump, which puts it back up to the top. It puts it back up to the top, in fact, by way of a tank, which is a soda bottle. And then in the bottom of that tank, there's a little hose with a small metal mesh filter, so that grains larger than that can't go back up through the system. Interestingly, it turns out that if you've got if your tank is pressure sealed, and you're pulling from the tank, that is causing the air pressure in the part of the tank that's not filled with oil to decrease, which creates a partial vacuum, which sucks it in. So you only need one pump, even though you've got this tank in line. Which is one of the reasons why I'm using a soda bottle, because they come already pressure tight. Boom, 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 boom. That doesn't work wonderfully well, because we've only got a small surface area on the hose. On the filter, rather, so the filter can clog up. And there's too much room for all of your grit, including the grit that is of the correct size, to settle. So that's going to need quite a bit of reworking. Also because I want multiple filters in line, so that it categorizes the grit as it goes. But it has actually lapped things to flattish. Which, yeah, was the point.
How do you measure how flat it actually is?
So, mostly, to be honest, I don't. I look at how scratchy it is. There are devices for that. I do have a very cheap, horrible depth caliper, which is actually a tire tread caliper, which, can attempt to measure this, but at the sort of level that a professional lapping machine would be looking for, you would need professional level measuring tools, which I do not possess because I'm a cheap ass. It does, however, generate a nice smooth surface, which in most respects is very similar to a nice flat surface. So I feel like it's probably doing pretty well. And yes, those were a lot of weasel words in there.
I guess it's going to be, the end result is going to be a nice shiny surface, so you can probably use something like a laser and mirrors and stuff like that to work out just how much deflection there is on the surface.
I like that plan. That is a very good plan. Sorry, I have to admit I am slightly running short on content here.
That's fine. Yeah.
showing us what it is. I want to see it working.
Are you ready?
Yeah, it is.
Are you ready?
Yeah, go.
This is from a while ago because currently it's sat in a box on the floor over there somewhere.
Sorry, this is quite so jumpy. The machine playing the video is also recording the video at the same time. But yeah, one of the all the indications it was walking, in fact, was you could very clearly see the toning pattern that Josh's lathe walk left in the top, being smoothed out and replaced with a beautiful mirror finish, which unfortunately at some point I managed to mar with a perfectly circular indentation where the part that I was lapping had caught and gouged.
It's okay, we can lap it again.
But yes, it's okay, we can lap it again. Yeah, so the current state is mostly that the prototype walked. We started thinking about the full-size version, which is based on a kitchen cabinet, a big garden tray from eBay, the bed and motor, and a couple ancillary bits, possibly, of the big pillar drill that was in the space for a while. So, yeah, that's going to be a fairly large machine. It is somewhat larger than a kitchen countertop, than a kitchen cabinet, because the size of the table is the size of the bed from the pillar drill is just a little bit too large.
It's about half a metre across and then 50 centimetres.
But yeah, was a bit of a challenge in that to get everything to fit, you end up needing a right angle, and for it to rotate at roughly the right speed, you need about a 50-to-1 speed reduction off of the motor we've got. So we actually managed to make a worm gear reduction right angle gearbox, which is to say mostly Josh made it, but I would say about half of the lathe work. And that actually works surprisingly well, at least when I've, got it in my hands and I'm turning it by hand, because the actual work to attach it to the motor or the bed isn't there yet. Like I said, we got somewhat distracted. And also, we kind of need a lathe in order to, build the parts that attach A to B to C.
Is there a particular speed it needs to spin at?
So, I'm not real sure. Commercial ones run at about 30 RPM, so that's what I've been aiming for. If you go too fast, then everything will just end up being unstable. There's almost certainly going to be a sweet spot where you're getting the most actual abrasive action, and thus, finishing parts as quickly as possible.
Yeah, makes sense, I suppose.
Lucky the motorized pulley.
Yeah, but mostly I want to be in the right ballpark, and there's going to be a set of pulleys on it, so you can adjust the speed to some degree, even without using an ESC, which I might end up doing. Even on the prototype, I had some fun trying to get a reasonable amount of abrasive flow for the speed that it was rotating at, because the pump and the motor were running off of the same supply, but I got that sorted. Yeah, so yeah, that's kind of what we need to do to actually make the full-size version usable. That is, except for changing around the way the slurry gets filtered, that is mostly a matter of JFDI, which honestly is what I'm bad at. So yeah, more questions? Jess, you have much to add?
Can't really think much to add, to be honest. Yeah, I think we're mostly stuck because we've got an axle that we took out of the Peladrill, and we want to resize it to fit into that gap between the left of the gearbox through the pulleys and into the side of the cabinet, in order to mount the pulleys that turn the table, and then hopefully we can mount the motor, put a thing that attaches the pulleys together, and spin the whole thing up. But we're stuck without that axle at the moment, and we need the lathe at the space, or somebody else at the lathe, I guess, to turn that down, or find another one to turn to a right shape. Anyone got any ideas or thoughts about it?
Not really, no. Just, yeah, interesting. I'd be interested to see something that's come off it, to see how flat it is.
Yes, for a sense of timescale, we did all the mini lathe we did during lockdown 1, I think. So March to starting in March for a couple of months, and then it's only been a little bit stalled in the middle somehow while we were trying to get the bits for the big one. Yeah, I'd also like to see some more things come off of it. To be honest, we could lap you some tiny nuts on the small one.
Yeah, also, I'm afraid that my box of random junk that I have lapped is also my box of random junk that I play with at my desk, and the lap surfaces have mostly been sanded down again.
Oh, you can fill them back up at some point.
Yeah, happen, isn't it?
Indeed. Well, thanks very much for listening to me.
Yeah, thank you.